An inspector may require ground fault circuit interrupter protection for a 120-volt circuit powering an intrinsically safe relay. The reasoning behind this often stems from several factors. Firstly, the lack of underwriters' laboratories or all listing is a primary concern. UL is a well-known safety testing and certification organization. If an intrinsically safe relay lacks a UL listing, it means the device has not undergone the rigorous testing procedures necessary to ensure its safety under various operating conditions. Without this certification, there is an increased potential for electrical hazards. Secondly, even though a relay is designed to be intrinsically safe, the 120-volt circuit that powers it can still present electrical hazards if a fault occurs. These hazards can include electrical shock, fire, and damage to equipment. Therefore, additional safety measures, like ground fault circuit interrupters, are often deemed necessary. Thirdly, electrical codes in some jurisdictions may mandate ground fault circuit interrupter protection for circuits that supply power to equipment that does not have a UL listing. This requirement is in place to reduce the risks associated with non-listed equipment. A ground fault circuit interrupter is a device designed to monitor the electrical current flowing through a circuit. If a ground fault is detected, meaning that current is leaking to ground through an unintended path, a ground fault circuit interrupter is designed to quickly interrupt the circuit. This rapid interruption helps prevent electrical shock and reduces the risk of fire. The inspector may have specific concerns related to the particular installation or application of the intrinsically safe relay. It is important to consult with a qualified electrician to ensure that the entire installation adheres to all relevant codes and safety standards. In conclusion, the requirement for ground fault circuit interrupter protection is often based on concerns regarding the absence of a UL listing for the intrinsically safe relay and the potential electrical hazards related to the 120-volt circuit that powers it. Ground fault circuit interrupter protection adds an extra layer of safety, mitigating these potential risks. The National Electrical Code, or NEC, provides guidelines for ground fault circuit interrupter protection. NEC Section 210.8 covers ground fault circuit interrupter protection for personnel. It specifies locations where ground fault circuit interrupter protection is required for 120-volt through 240-volt receptacles. While this section focuses on receptacles, the principle of ground fault circuit interrupter protection can be extended to other equipment based on the specific circumstances and local interpretations of the code. For example, if the relay is located in an area where there is an increased risk of electrical shock, such as a wet or damp location, the inspector might require ground fault circuit interrupter protection, even if it is not explicitly mandated by the NEC for that specific type of equipment. The lack of a UL listing raises concerns about the equipment safety and performance under fault conditions. Inspectors may use their discretion to require additional safety measures like ground fault circuit interrupter protection to compensate for the uncertainty introduced by the non-listed equipment. Ground fault circuit interrupters work by monitoring the current balance between the supply and return conductors of a circuit. In a normal circuit, the current flowing through the hot wire should be equal to the current flowing back through the neutral wire. If there is a difference of 6 milliamps or more, it indicates that current is leaking to ground, which could pose a shock hazard. The ground fault circuit interrupter will trip, quickly interrupting the circuit to prevent injury. In industrial settings, intrinsically safe circuits are often used to prevent explosions in hazardous locations. These circuits are designed to limit the amount of energy available, so that even in the event of a fault, there is not enough energy to ignite flammable gases or vapors. While the intrinsically safe relay itself may be designed to limit energy, the 120-volt circuit powering it is not intrinsically safe. Therefore, if a fault occurs in the 120-volt circuit, it could still pose a hazard. Ground fault circuit interrupter protection helps to mitigate this risk by quickly interrupting the circuit in the event of a ground fault. The inspector is responsible for ensuring that electrical installations are safe and comply with all applicable codes and standards. They have the authority to interpret the code and require additional safety measures if they believe it is necessary to protect people and property. In the case of a non-UL listed intrinsically safe relay, the inspector is likely exercising their professional judgment to require ground fault circuit interrupter protection as an extra layer of safety. It is essential to address any concerns raised by the inspector and to ensure that the electrical installation is safe and compliant. Consult with a qualified electrician or electrical engineer to review the installation and determine the best course of action. They can assess the specific circumstances and recommend appropriate safety measures to ensure the safety of personnel and equipment. Understanding the NEC, specifically articles related to ground fault protection and equipment listing, is crucial for electrical professionals. Article 100 defines approved as acceptable to the authority having jurisdiction. This definition gives the inspector the power to make judgments based on safety. Article 110.3b covers examination, identification, installation, and use of equipment. It states that listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. This reinforces the importance of UL listing and following manufacturer instructions. Article 250 addresses grounding and bonding. It provides requirements for grounding electrical systems and equipment to minimize the risk of electrical shock. Ground fault circuit interrupters are an important part of a comprehensive grounding system. Article 500 through 516 cover hazardous locations. These articles provide requirements for electrical equipment installed in areas where flammable gases, vapors, or dust may be present. Intrinsically safe circuits are commonly used in these locations, but as discussed, the 120-volt power supply to the intrinsically safe relay may still require ground fault circuit interrupter protection. NEC Section 504.4 covers intrinsically safe apparatus. It requires that intrinsically safe apparatus and associated apparatus be installed in accordance with the requirements of the article. This includes ensuring that the power supply to the intrinsically safe apparatus is properly protected. The inspector's decision to require ground fault circuit interrupter protection is based on a combination of factors, including the lack of UL listing, potential electrical hazards, and code requirements. Ground fault circuit interrupter protection provides an additional layer of safety mitigating these risks. Always consult with a qualified electrician to ensure that electrical installations are safe and compliant. To further clarify the need for ground fault circuit interrupter protection, consider the potential scenarios that could arise even with an intrinsically safe relay. Imagine a scenario where the insulation on the 120-volt wiring feeding the relay becomes damaged. This damage could be caused by physical abrasion, aging, or even rodent activity. If the damaged wire comes into contact with a grounded metal enclosure or a person, it could create a path for current to flow to ground, resulting in an electrical shock hazard. Even though the relay itself is designed to limit energy in its output circuit, the 120-volt supply is not inherently current limited. Therefore, a ground fault in this circuit could deliver a significant amount of current, posing a serious risk. The ground fault circuit interrupter would detect this imbalance and quickly trip the circuit, preventing a potentially fatal shock. Another scenario involves the surge on the 120-volt line. Surges can be caused by lightning strikes, utility switching, or other electrical disturbances. While surge protective devices can help to mitigate these surges, they are not foolproof. A large enough surge could still damage the relay or other components in the circuit, potentially creating a ground fault. Again, the ground fault circuit interrupter would provide protection by quickly interrupting the circuit. Furthermore, consider the environment where the relay is installed. If the relay is located in a damp or wet environment, the risk of a ground fault is increased. Moisture can create a conductive path between the electrical components and ground, making it easier for current to leak. In these situations, ground fault circuit interrupter protection is particularly important. The inspector's decision is not simply about blindly following rules, but rather about assessing the specific risks present in the installation and taking appropriate measures to mitigate those risks. They are considering the potential consequences of a fault and implementing safeguards to protect people and property. The inspector may also be considering the overall condition of the electrical system. If the system is old or poorly maintained, there may be an increased risk of faults. In these cases, they may be more likely to require additional safety measures like ground fault circuit interrupter protection. The inspector's role is to be a safety advocate, ensuring that electrical installations are safe and compliant. While it may be inconvenient or costly to install ground fault circuit interrupter protection, it is a worthwhile investment in safety. It can help to prevent electrical shocks, fires, and other hazards, protecting people and property. Remember to always consult with a qualified electrician to ensure that electrical installations are safe and compliant. They can assess the specific risks present in the installation and recommend appropriate safety measures. Understanding the NEC and local electrical codes is essential for electrical professionals. Stay up to date on the latest requirements and best practices to ensure the safety of electrical installations. Consider the practical implications of not having ground fault circuit interrupter protection in this scenario. Without ground fault circuit interrupter protection, a ground fault could go undetected for a significant period of time. During this time, the fault current could be flowing through a grounded object or a person, creating a continuous shock hazard. The amount of current required to cause a fatal shock is relatively small, often less than 100 milliamps. A standard circuit breaker may not trip until the current reaches 15 amps or more, which is far above the level that can cause serious injury or death. Ground fault circuit interrupters are designed to trip at much lower current levels, typically around 6 milliamps, providing a much faster and more effective response to ground faults. This rapid response can significantly reduce the risk of electrical shock. In addition to the risk of electrical shock, a ground fault can also cause a fire. Fault current can generate heat as it flows through the unintended path to ground. If this heat is concentrated in a combustible material, it could ignite a fire. Ground fault circuit interrupters can help to prevent these fires by quickly interrupting the circuit before the fault current can generate enough heat to cause ignition. The inspector is considering these potential consequences when making their decision to require ground fault circuit interrupter protection. They are weighing the risks against the costs and benefits of the protection and making a judgment based on what they believe is the best course of action to ensure safety. It is important to remember that the inspector is not trying to be difficult or unreasonable. They are simply trying to do their job and protect people and property from electrical hazards. By understanding the reasoning behind their decision, you can work together to find a solution that meets both your needs and the safety requirements. The ground fault circuit interrupter protection requirement also aligns with the general principle of defense in depth. Defense in depth is a safety strategy that involves implementing multiple layers of protection to reduce the likelihood of a hazard. In this case, the intrinsically safe relay is one layer of protection designed to limit energy in the output circuit. However, the 120-volt power supply is a separate layer, and it may require its own protection in the form of ground fault circuit interrupter protection. By implementing multiple layers of protection, the overall safety of the system is increased. Even if one layer fails, the other layers can still provide protection. This approach is particularly important in situations where the consequences of a failure could be severe, such as in industrial settings where flammable materials are present. In summary, the inspector's decision to require ground fault circuit interrupter protection for the 120-volt circuit powering the intrinsically safe relay is based on a sound understanding of electrical safety principles and a consideration of the specific risks present in the installation. It is a proactive measure designed to protect people and property from electrical hazards. It is important to take their concerns seriously and work together to find a solution that meets both your needs and the safety requirements. Always consult with a qualified electrician to ensure that electrical installations are safe and compliant. They can assess the specific risks present in the installation and recommend appropriate safety measures.